Well, hello ladies and gentlemen, welcome to our first video to try and explain to you a few pointers about your colloidal silver kit, which hopefully you have just received in the mail. And you may wonder, what is the next step? Well, first of all, you might like to calculate the parts per million for a particular water. You will notice on the website that I've already assessed a number of waters which are readily available at Coles and Aldi's and Woolies, and from that you're able to easily calculate the time needed to run your colloidal silver generator to achieve a certain parts per million. But anyway, you might want to know how to do that. So we'll just show you how to do the calculation, because included in your kit is the electrical production of silver ions for the preparation of colloidal silver. And there we have laid out the mathematics so that whatever water you are using, you can calculate the parts per million. Now there are two factors we need in order to do that. One is the current passing through the water, and two, the volume of the container that you are processing. Now in this case we've provided you with a coffee jar, even with the coffee in it. So once you've decanted the coffee and cleaned the jar, you're all set to go. And that works out at about 0.770 millilitres of fluid, and you can do the calculations on that volume. The second parameter is the current. Now I have a little test unit here where we don't have the fancy top, and the wires are exposed for easy hooking up a multimeter, which you can see there. So this is the positive, where the resistor comes out of. So we hook the positive meter terminal to that, and the negative one, which goes straight to the colloidal silver probe. And already you can see some action in there. If I move this wire out of the way, and we'll try and get a bit of a close-up on the action down there in the cell. We'll just let that run and settle down for a minute. You can see one probe is producing the silver ions and particles, and the other probe is inactive as far as what it's putting out bubbles, which is the hydrogen. Okay, now on my calculations, we've calculated it for 20 minutes running of being around the 10 parts per million. If you want more than that, you just simply double the time, and you can look up the table on the web and download that from your free info pack. Alright, well that's running now, and we're running at 7.1 milliamps. If I zoom in on the meter, and there you have it. So that's what we use to calculate the parts per million. That's the figure we need. Alright, and that will vary with different mineral waters, as you will see on the table provided. And there she is, busy at work there, and that's the sort of thing you should see. If I can get that in focus. There you are, doing a nice action. So that will become a silvery grey, and now this particular one does not have the UV light in it. The one that's provided will have the UV LED, and that will give a purple glow. But we'll explain a little bit more about that later. Okay, well let's have a look at the maths. Now here you see a brief explanation. You need to multiply Q to find the Coulomb charge is the current times the time, and in this case we've used 300 seconds, just 5 minutes. In my other calculations I've used 10 minutes, which is 600, but whatever time you want to calculate it on, you multiply the two together, and in this case you've got 0.0085, which is 8.5 milliamps on the example given here. On my meter it's 7.12, so if I was to recalculate it, it would be 7.12 by 300. I can't do that in my head, but that's the first stage. Now, the electrical charge can be divided by Faraday's constant to find the number of moles of electrons transferred. So the moles is Q, which we've just worked out, and in this case is 2.55 coulombs, divided by Faraday's constant. And that gives you a pretty interesting number. Usually has 4 zeros in front of it. In this case it's 0.00002643 moles. Okay. Now, since silver forms a singularly charged ion, the number of moles of electrons transferred is equal to the theoretical maximum amount of ionic silver produced. Now, if we multiply the number of moles of silver by the atomic mass of silver, we get the maximum mass of silver oxidized in grams. So that's the mass silver equals the moles by the atomic mass. So we've already divided it, the charge, the Coulomb charge, and that gives us that big number there. And down here we multiply it by 107.87, which is the atomic mass, and that gives us 0.00285 grams. And then we convert that to milligrams by multiplying it by 1000, which is 2.85 milligrams. So then the end result is, to find the parts per million, we divide that by the volume, and in this case it's 2.85 divided by 0.077, which is 3.7 parts per million. So in this case, if you double the time from 5 minutes to 10 minutes, that would give us 7.4 parts per million, I believe. So that's the basic rundown of the mathematics, and I hope that helps you to be able to calculate the parts per million for any given water in any given cell. So thank you for listening.